Welcome back to the Nocturnal Astronomer. I'm your host, Atlas Reed. Here's a strange thought to start with. The gold in a ring on your hand, the calcium in your bones, even the iron carried in your blood, all of it was forged inside a dying star, billions of years before you ever arrived to carry any of it. Tonight, we're talking about supernovae, the moments when massive stars reach a bright, final change. It sounds dramatic, and it is, but stay with me. Once you see the true scale of it, these events become something gentler than worry, a reminder of how small our troubles are, and how much of the universe's oldest, quietest patience is already woven into you. Let's dive in. Fact 1. A dying star's warning arrived hours before its light. In February of 1987, a star came apart in a smaller galaxy near our own, a hazy companion called the Large Magellanic Cloud, about 168,000 light-years from where you lie now. Instruments buried underground, sealed from daylight, caught something never caught before. Detectors in Japan, the United States, and the Soviet Union each registered a short burst of tiny, weightless particles called neutrinos. These particles arrived roughly 2 to 3 hours ahead of the visible light from the same explosion, a gap that sounds small until you weigh the distance already crossed. The whole burst lasted under 13 seconds. Fewer than 30 of these particles were caught among the 3 stations, out of the uncountable trillions that must have swept through the planet and through your body in that same short window, leaving no mark at all. Why would the messengers arrive before the light? Because light is born near the surface of a star and has to fight its way outward through crowded layers of matter, while neutrinos barely notice matter is there. They slip through almost everything, including us, including the walls around you now. This tiny burst confirmed decades of careful thinking about how a massive star's center gives way. Physicists had guessed at this collapse in theory for years, and here, finally, was a quiet whisper from an actual dying star, arriving as a handful of nearly nothing. Consider what that means for scale. A star more than 100,000 light-years away sent a signal that passed through your body before you could even notice, before the light reached the sky, and before anyone on Earth understood what had happened. There is something soothing in that delay. 2 or 3 hours is nothing against a journey of 168,000 years. Your own worries, the ones that keep circling tonight, are asking for urgency on a scale the universe does not use. The universe does not rush. A star can quietly send its first whisper across a gap that light itself needs many lifetimes to cross, and still take its unhurried time before showing us the rest. Nothing about that explosion demanded your attention sooner than it arrived. You are, this very moment, being passed through by particles born in explosions so far away that their light has not yet reached you and will not for years to come. You are already part of a conversation that stretches farther than worry can follow. So let the evening slow down the way that starlight does. Nothing you are carrying tonight needs to travel 168,000 years to reach you. It is already here, already small, already something you can set down and let rest beside you until morning. Fact 2. A spoonful of a dead star outweighs a mountain. After certain massive stars finish their explosion, something impossibly dense is often left behind at the center. A small sphere called a neutron star. It might be only about 20 kilometers across, roughly the width of a modest city, yet it holds more mass than our entire sun. To make room for that much mass in so little space, the star's remaining matter is squeezed until ordinary atoms simply cannot exist anymore. Electrons and protons are pushed together until they merge into neutrons, and the empty space that once sat inside every atom disappears completely. The result is astonishing to picture. A single teaspoon scooped from a neutron star would weigh somewhere around 1 billion tons here on Earth, more than the combined weight of every car and truck built across an entire decade, all held in one small spoon. Neutron stars often spin, some completing a full turn many times each second, steady and metronomic, sweeping narrow beams of radio waves past us like a lighthouse turning in the dark. Astronomers first noticed one of these signals in 1967 and were startled by how precise it was. That precision is worth resting on. A dead star, the leftover core of something that once burned itself out, can keep better time than almost anything built by human hands. It does this quietly, without asking to be admired, simply because that is what its nature allows. There is a kind of steadiness hidden inside even the grandest endings. A star's outer layers can be thrown outward, its brightness flaring for the whole galaxy to notice, and still, at the very center, something settles into a rhythm precise enough to set instruments by. You do not need to hold 1 billion tons of anything to matter. The comparison is not meant to make you feel small in a cruel way, only to remind you how strange and layered this universe is, how much strangeness quietly exists without asking you to solve it. Let your body feel heavy, the way a spoonful of that star would feel heavy in your palm, except your weight is soft, forgiving, easy to release. You are made of gentler material than a neutron star, built to rest rather than to pull tightly inward. So breathe out slowly and let your shoulders sink the way that stellar matter once sank inward. There is nothing punishing in this comparison, only a reminder that density and gentleness can both exist in this universe, and that tonight only the gentle kind is asked of you. Fact 3. A new star lit the daytime sky for weeks. In the summer of 1054, in the year we now write as an old memory, court astronomers in China noticed a new star appear where nothing had been before, near the horn of the constellation we call Taurus, the bull. They called it a guest star, a phrase that already sounds gentle, almost like something welcomed rather than something feared. It shone far brighter than the planet Venus, and observers described its color as reddish-white, with faint points of light reaching outward in 4 directions. For about 23 days, that guest star could be seen even during the daytime, competing quietly with the sun itself. It stayed visible at night for close to 2 full years, a season of the sky changed by a single distant event that no one on Earth had caused. Halfway across the world, in what is now Arizona, other watchers seem to have noticed the same event. Rock carvings near ancient dwellings show a crescent moon beside a bright star, roughly where that guest star would have appeared, a quiet echo across 2 very different cultures. What those watchers saw, without any way to know it, was the outer layers of a star thrown outward at astonishing speed, unveiling a small, dense center, much like the one we described earlier. They only knew that the sky had changed, and they wrote it down with care. Centuries later, telescopes revealed a soft, glowing structure at that same location in the sky, now called the Crab Nebula, still expanding outward gently, still growing wider with every passing year, a slow bloom that began before a single person alive today was born. It is worth sitting with how long that bloom has continued. Ordinary people once looked up and saw a temporary brightness, gone within a season, while overhead, unnoticed and unhurried, its aftermath has continued softly expanding for nearly 1,000 years and will keep doing so. There is comfort in a story that stretches this long without urgency. The people of 1054 went back to their ordinary days after the guest star faded, tending gardens, raising children, finishing quiet tasks, while the universe kept unfolding at its own patient, generous pace above their heads. Your own week, however loud it feels right now, is a small season inside a much longer bloom. Whatever seems urgent tonight will also eventually soften into something you glance back on, the way we glance back at a guest star from 1,000 years ago, gently, without alarm. So let tonight be an ordinary evening, the way that summer once was ordinary, before anyone knew a star was quietly changing shape overhead. You do not need to solve everything before sleep. The sky continues its slow work, whether or not you are awake to watch it. Fact 4. Faraway explosions reveal the universe stretching ever faster. A certain kind of star explosion, called a Type 1a supernova, behaves with unusual consistency. It happens when a small, dense white dwarf star gathers just enough extra material to cross a threshold, and it always seems to release roughly the same amount of light at its peak. Because that peak brightness is so dependable, astronomers began using these explosions as standard candles, tools for measuring distance across the universe. If you know how bright something truly is up close, comparing that to how dim it looks from here tells you how far away it sits. In the late 1990s, two independent teams of researchers set out to measure dozens of these faraway explosions, hoping to learn whether the universe's outward stretching was slowing down over time, the way falling bodies eventually slow under gravity's steady pull. What they found instead surprised everyone involved. The explosions were dimmer than expected, which meant they were farther away than expected, which meant the universe was not slowing its stretch at all. It was gently but unmistakably stretching faster with each passing year. This quiet surprise reshaped how we understand everything around us. Whatever is causing that gentle acceleration was given a name: dark energy, though its true nature is still being explored today, still one of the more open questions in modern astronomy. In 2011, 3 of the scientists behind this discovery received the Nobel Prize in Physics, honored for a finding that began with careful counting of distant stellar explosions, patiently gathered one faint flare at a time across many years of quiet observation. There is something calming in knowing the universe is still stretching, still opening outward, still becoming roomier rather than closing in. Whatever feels tight or narrow in your evening tonight exists inside a universe that is, at this very moment, gently making more space. You might picture it like a room whose walls are slowly moving outward while you sleep, not urgently, not all at once, but steadily, softly, every night, every year. There is more room tonight than there was yesterday, more room than there will ever stop being. None of this stretching asks anything of you. It happens whether you are anxious or calm, awake or dreaming. And it will keep happening long after tonight's particular worry has faded from memory, the way nearly every worry eventually does, given enough patient time. So let your thoughts loosen, the way the universe itself is loosening, expanding gently rather than tightening. You are allowed to take up a little more room tonight, to breathe a little wider, resting inside a universe that is quietly doing the very same thing. Fact 5. A single explosion can outshine an entire galaxy. For a short window, at its very brightest, a supernova can shine with roughly 1 billion times the brightness of our own sun, concentrated into one small point of light. For a few weeks, that single point can outshine every other star in its home galaxy combined. Try picturing your own galaxy, the Milky Way, home to more stars than anyone has ever managed to count by hand, somewhere in the hundreds of billions. Now, imagine one single dying star, briefly, quietly, outshining every last one of them at once, then fading again. This is not a slow, gradual brightening. Within days, a supernova's light can climb by roughly 10 steps on the scale astronomers use for brightness, an enormous jump, before settling into a gentle decline that can stretch across many months. And then, almost as suddenly as it arrived, it fades. The blaze that outshone 100 billion stars quietly dims back down, leaving behind only an expanding shell of glowing gas, and sometimes a small dense leftover, like the neutron star we described earlier. There is something reassuring in how briefly even the grandest events in this universe actually last. A supernova's dramatic peak, the part that outshines a galaxy, occupies only a small sliver of the star's entire existence, most of which was spent shining quietly for millions of years. Your most overwhelming moments are like that too. They arrive, they burn bright for a while, demanding your whole attention, and then they settle back down into something quieter, leaving behind only the shape of what happened, softened by time. It can help to remember that brightness is not the same as importance. A supernova's blaze is spectacular, yes, but the star's long, patient decades of quiet shining mattered just as much, simply without announcing themselves the way that final flare did. Whatever feels loudest in your life tonight, whatever worry is currently outshining everything else in your thoughts, is very likely a brief peak rather than a permanent condition. Like the supernova's blaze, it will not hold the sky forever, however vast it feels right now. So let the brightness in your mind dim a little, the way even galaxy outshining light eventually settles back into a gentler glow. You do not need to solve the loudest worry tonight. You only need to let it begin its own quiet fade toward rest. The afterglow that follows a supernova's peak can still be seen for months, slowly fading rather than vanishing all at once. Even endings arrive gently, given enough patience, softening at their own pace rather than closing the instant their brightest moment has finished passing overhead. Fact 6. Almost none of a supernova's light show is actually light. Here is something that surprises even people who study this closely. When a massive star's center collapses and rebounds in an explosion, roughly 99% of the total energy released escapes as neutrinos, those same nearly weightless particles we described earlier, not as visible light at all. The dazzling flash that outshines a galaxy, the part any observer on Earth could actually notice and admire, is only the smallest remaining sliver of the whole event. Almost everything else slips away instantly, invisibly, carried off by particles that pass through solid matter as though it were not there. It is a strange kind of honesty about how the universe works. The part we can see, the part that becomes stories, drawings, and centuries of written wonder, is a tiny fraction of what actually happened. Most of the true event unfolds where no eye could ever have followed it. Think about how much of your own life follows that same shape. The visible parts, the moments other people notice and comment on, are often the smallest fraction of everything actually happening inside you, most of which unfolds quietly, invisibly, in a place no one else can fully see. That is not a lonely thought, it is a freeing one. A star does not need every part of its ending to be witnessed for that ending to matter. The unseen 99% is just as real as the flash, simply less inclined to announce itself. You are allowed to carry things that never become visible to anyone else. Whole seasons of feeling, whole quiet unfoldings can matter fully, even if no one around you ever notices them, the same way a star's truest release of energy leaves almost no visible trace at all. There is also something gentling in knowing that even at its most dramatic, a star is mostly working in a hush. The blinding part is small, the greater part is quiet, nearly undetectable, slipping past everything without needing anyone to watch it happen at all. So tonight, let whatever feels unseen inside you be enough as it is. You do not need a visible flare to prove that something real is happening, that something is settling, releasing, moving toward its own quiet kind of rest, however invisible that process may feel from the outside. Even the neutrinos that do the real work travel almost undetected, slipping through walls, through mountains, through your own body without leaving any mark. The universe seems comfortable letting its most essential work happen when nobody is watching, asking nothing in return for any of it. There is no need to perform your ending or your unfolding for anyone else to witness. A star's truest release happens quietly, in the dark, and still changes everything around it, the same way your own quiet feelings can matter fully without ever needing an audience. Fact 7. The calcium in your bones was forged inside a star. Every atom heavier than hydrogen and helium in your body has a history that begins inside a star. Carbon, oxygen, calcium, iron, nearly everything that makes up bone, blood, and breath was built through nuclear fusion deep within stars that finished their existence long before our sun was born. Massive stars spend their final stretch fusing progressively heavier elements in their center. Hydrogen into helium, helium into carbon and oxygen, layer after layer building outward like the rings of a tree, each new layer forged only once the one beneath it has been exhausted. When such a star finally collapses and releases its energy outward in a supernova, it scatters those hard-won elements across the surrounding space, seeding nearby clouds of gas and dust with the very materials that will later become new stars, new planets, and eventually new bodies. This means the calcium currently holding your skeleton together, the iron carrying oxygen through your bloodstream at this very moment, was not made on Earth at all. It was made inside a star that finished its existence long before our solar system had even begun to take shape. There is an old, gentle way of putting this, that we are made of the same material as stars. Quite literally, atom for atom. Not as a poetic exaggeration, but as a fact, worked out carefully by astronomers, studying how elements form and how they travel across the galaxy. Consider that the next time you feel disconnected from anything larger than your own evening. The very calcium letting you stand, the very iron letting you breathe, arrived here after traveling across unthinkable distances and unthinkable stretches of time, carried outward by a star's own quiet, generous ending. You did not choose this connection, and you do not need to understand it fully for it to be true. It sits inside you already, settled and complete, a kind of inheritance older than any worry currently keeping you awake, older than language, older than the idea of worry itself. So let your body feel for a moment like the patient result of something enormous and slow. You are not apart from the stars you are looking up toward. You are continuous with them, built from their leftover generosity, resting now in a form quiet enough to fall asleep. Fact 8. Our solar system may owe its birth to an exploded star. Ancient meteorites, some of the oldest material anyone has ever studied, contain tiny amounts of a particular kind of aluminum, one that decays away within a few 100,000 years, far too quickly to have simply drifted in from somewhere ordinary and far away. Its presence tells astronomers something remarkable, that this aluminum must have been freshly made and delivered into the cloud of gas and dust that became our solar system, and delivered quickly, while that cloud was still gathering itself together into what would eventually become the sun and planets. One leading explanation, supported by careful modeling, suggests a nearby star exploded around that same time, sending outward a shockwave that carried freshly forged material into the collapsing cloud, while also giving that cloud the gentle push it needed to begin pulling itself together. Picture that quietly for a moment. Long before Earth existed, before there was a sun to rise or set, a star somewhere nearby finished its existence, and in doing so may have helped nudge a formless cloud of gas into becoming the very system you are lying inside tonight. Nothing about your evening would exist without that ancient, unseen event. No sun to have set outside your window today, no earth to have shaped an ordinary afternoon, no body of yours built from elements gathered by that same collapsing, star-touched cloud so long ago. It is a strange kind of gratitude to feel towards something that happened billions of years before you, toward a star whose name we will never know, whose ending we can only infer from faint chemical traces preserved inside rocks that have fallen from the sky. And yet the gratitude still fits. Whatever helped assemble the very ground beneath your house, the very air filling your lungs right now, deserves a quiet kind of acknowledgement, even if it happened in silence, unwitnessed, long before anyone existed who could have noticed it at all. So let tonight carry a little of that old debt lightly. You are here partly because something ended, gently and productively, an unthinkably long time ago. That ending was not a loss so much as a beginning everything you are still, quite literally, made from and resting inside. Fact 9. Our galaxy has shown no supernova since 1604. In 1572, a Danish astronomer named Tycho watched a new star appear in the constellation Cassiopeia, bright enough to be seen without any instrument at all at a time before telescopes even existed to help anyone look closer. Just over 3 decades later, in 1604, another new star appeared, this one studied closely by the astronomer Johannes Kepler, who tracked its brightness and position with careful, patient notes across many months as it slowly dimmed back into the ordinary night. Since that year, 1604, no supernova has been seen with the naked eye anywhere inside our home galaxy. More than 4 centuries have passed since anyone on Earth simply looked up and noticed a brand new star appear where nothing had been the night before. This is not because such explosions have stopped happening. Astronomers reckon our galaxy experiences a handful of these explosions every century, but most are hidden from view, tucked behind thick clouds of dust near the crowded center, unseen by anyone standing here on Earth. So, the naked eye supernova is not rare because the universe is quiet. It is rare because our angle, our particular corner of a very large galaxy, happens to make most of these events invisible to us, hidden gently behind curtains of gas we simply cannot see through. There is something comforting in that kind of quiet. Enormous things can be happening constantly, all around us, without ever announcing themselves to your particular evening. The universe does not need your witness in order to keep unfolding exactly as it always has. 400 years is a long human stretch, long enough for entire family lines to rise and fade, long enough for languages to shift, and still, from the perspective of a galaxy that has existed for more than 10 billion years, it barely registers at all. Whatever feels like it has been going on forever in your own life, whatever worry has worn a groove into your evenings, is still, in truth, closer to a single passing season than to anything permanent, however patient or slow-moving it might currently feel to you. So let tonight be one quiet evening inside a much longer, much gentler unfolding. You do not have to witness every enormous thing happening around you to trust that most of it is proceeding calmly, unseen, without needing anything urgent or dramatic from you at all. Fact 10. Betelgeuse could explode and still pose no danger. Not far from the three familiar stars of Orion's belt sits a reddish giant named Betelgeuse, easily visible on a clear night, marking one shoulder of the hunter. Astronomers consider it one of the more likely stars nearby to end its existence in a supernova. It sits roughly 600 light-years away, a distance so large that the light reaching your eyes tonight actually left that star centuries ago, long before anyone alive today was born, long before most of the buildings around you were even standing. When Betelgeuse finally does explode, and it may happen soon in astronomical terms, though that could still mean tens of thousands of years from now, it will briefly brighten to roughly the brilliance of the full moon, visible clearly even during the daytime for weeks. And that is the whole story, as far as any danger goes. Researchers who study this closely have found that a star would need to sit within roughly 50 light-years of Earth for its explosion to meaningfully affect us, and Betelgeuse sits many times farther away than that. So, the nearest candidate for a naked-eye supernova in our modern age offers only a spectacular, harmless light show, a temporary extra moon-shaped point in the sky, gone again after a season, leaving nothing behind that could reach us here in any way that matters. There is something quietly reassuring in that math. The universe's most dramatic remaining event within easy reach of our eyes turns out to be entirely gentle from where we stand, a reminder that scale and distance can turn even an explosion into something safe to simply enjoy. You could, one distant night, years or centuries from now, step outside and see a new point of light glowing beside Orion's familiar shape, and feel only wonder, no danger at all, because the universe has already arranged the distances generously, comfortably, entirely in your favor. That is, in a quiet way, how most of the universe treats us. Enormous, powerful, endlessly capable of astonishing events. And yet, from where we are lying tonight, almost entirely gentle, asking nothing more of us than a willingness to notice and rest inside its scale. And on that note, we come to the end of tonight's journey through dying stars, and I want to leave you with the thought sitting quietly underneath every fact we covered. None of this vastness is frightening. It only widens the room you rest in. A star far away sent particles through your body before its light even arrived. A spoonful of collapsed matter outweighs a mountain, quietly, without asking to be noticed. A guest star lit the daylight sky for weeks, then faded, and the world went on turning exactly as it always had. Distant explosions taught us the universe itself is gently stretching wider every year, making more room rather than closing in. A single dying star can, for a moment, outshine an entire galaxy, and then just as certainly settle back down into quiet, the way almost everything eventually does.
Nearly all of that dramatic energy leaves unseen, as particles no eye could follow, a reminder that the truest parts of an ending are often the ones nobody gets to witness. And still, that unseen ending matters completely, whether or not anyone was there to see it happen.
The calcium in your bones, the iron in your blood, were forged inside stars that finished their existence long before our sun ever began to shine. You are not apart from the sky above you tonight. You are continuous with it, built from its patient, generous leftovers. Our very solar system may owe its shape to a nearby star's ending, a shockwave that helped gather the cloud that became the sun, the earth, and eventually, quietly, you. Nothing about your evening exists apart from that old, unwitnessed kindness passed down across billions of years. Only twice in more than 4 centuries has a supernova been visible to the naked eye from here, a reminder that enormous things can be happening constantly without ever needing your attention, unfolding gently in places you will never see, on a schedule that owes you nothing at all. And the nearest star likely to end this way, Betelgeuse, sits so comfortably far from us that its eventual explosion will only ever be a harmless, generous light in the sky, offered freely, asking nothing back, a reminder that even huge moments can arrive without any danger at all. Rather than something to fear, the cosmos offers something closer to relief, a reminder that our daily worries, however loud they feel by lamplight, are small against something so impossibly vast, so unhurried, so endlessly patient with the small, ordinary evenings of a single quiet life like yours. Thank you for spending this time with me tonight, resting among dying stars and quiet endings that somehow became a kind of comfort. I hope some of that vastness settles into your chest and stays there through the night. Sleep well under a sky older than worry,